Okay, so today we're going to solve the unreleased Feb March 2026 paper 1, and it's what is it? 5:16 p.m. and the date is 13th April. So 13th April 2026. So me, I have not done this paper and I don't have the marking scheme. So let's see if I can do it in 2 hours. And let's go. So 5:16 is the time when we start. So let's see. What do we have here? Uh, Show that x plus 2 is a factor of px. So we use a factor theorem. P of minus 2 should be a 0. So 4 times minus 2 cube plus 8 times minus 2 square minus of minus 2 minus a 2 should come out to be a 0. Let's see. So 4 into negative 8 plus 8 into 4 plus a 2 minus a 2, and that actually comes out to be a 0. So x plus 2, since pf minus 2 is a 0, x plus 2 is a factor. So that was the first question. Let's go do the other one. Now show that px, you need to solve for px equals 0. Okay, so I'm going to do it on the right side here. Uh, px is a 0. I know that x plus 2 is a factor. So x plus 2 multiplied by some quadratic should be the cubic, 4x cubed plus 8x square minus a x minus a 2. And that means it's ax cube plus bx square plus 2ax square plus a 2bx plus a 2c equals the cubic there. I will club together the x square terms. So x square with a b plus 2a with a 2bx and a 2c should be equal to 4x cube plus a 8x square. And from here, I can see that simple comparison. I know that 2c must be equal to a minus 2. I know that a must be equal to 4. And I know that 2b should be equal to minus 1. Okay. So we go a is a 4, 2c is a minus 2, which means c is a minus 1. And b plus 2a, this thing here, should be equal to 8. So b plus 2 times 4 should be equal to 8, which means b is a 0. Okay. Why am I getting a b equal to 0 here? When I am getting a b equal to minus 1 by 2 from the other one. A is a 4, 2c is a minus 2, so c is a minus 1. Have I done a mistake somewhere? Let's see. Ax cube bx square plus cx. Okay, let's do it again. So x multiplies with all of them. You've got ax cube plus bx square plus a cx. And then the 2 multiplies with all of them. 2bx plus a 2c equals the cubic there. Okay. And you have ax cube plus x square with a b plus 2a and a x with a cx and a 2b. So you go 2b plus c. That was the mistake, I think. and the 4x cube plus a 8x square minus a x minus a 2. Now you know 2c is a minus 2, which means c is a minus 1. And you know a is a 4, and you know b plus 2a is a 8. So you go b plus 2 times 4 is a 8, which means b is a 0. Let's check. 2b plus c is a minus 1. So 2b plus c is a minus 1, which means 2b minus 1 equals minus 1, which means b is a 0 again. So yes, b is a 0. So the quadratic we get is x plus 2 into a with a 4 there, b with a 0, and c is a minus 1. So you are looking at x plus 2 into 4x square minus a 1. And you have factorized the cubic now. You want to equate it to a 0. That is what you wanted to solve. Px is a 0 is what you wanted to solve. So there it is, px in the factorized form. Well, good thing is I know that this is 2x squared minus a 1 square. So you are looking at x plus 2 into a square minus b square. That's a minus b into a plus b equals 0. So I'm looking at x equal to minus 2, 1 by 2, and minus 1 by 2. Well, those are your solutions. Okay, so that was question 1 part B. Okay, now let's go do the other one. Here they want me to sketch this quadratic. Okay, so let's see. Mm, it's for 4 marks here, so I'm going to go look for the critical points. State the intercepts with the coordinate axes. So I'm going to have to show them the y-intercept, the x-intercept. Okay, so, well, let's just go do x square minus 2x minus 3. Well, that factorizes to what? X square minus 3x. No, yeah, minus 3x plus x minus a 3. So that's basically x common out plus a 1. So x minus 3. So that's basically x plus 1 into x minus 3. And that's how I can get the um, x-intercept. And they come out to be minus 1 and a 3. I can also find out the y-intercept. Y-intercept is when x is a 0. Y-intercept when x is a 0. So it comes out to be y equal to 3. So 0 comma 3 happens to be the y-intercept of it. Oh, if we are looking at just the quadratic without that mod, it's a 0 comma minus 3. So we are gonna sketch the quadratic without the mod first, and then we're gonna reflect it. Okay, and we can also find the vertex. Vertex is supposed to be right in between the two. X-intercepts there comes out to be a 1, and the y corresponding to it will be a 1 minus 2 minus 3, and that's a 1 minus 5. That's a minus 4. So the vertex is supposed to be 1 comma minus 4. Okay. Hmm. So now we can sketch it. Let's see. Uh, let's get this turned into grids. Can I get grids here? Yes. Okay. Hmm. So we are looking at minus 1. Let's give them 2 units. 2 units. 1, 2, 3. That's 3 for us. And 1 comma minus 4. 1 comma. Oh, let's go do 1 unit on the y. So 2 boxes for 1 and one box for 1 on the y-axis. Okay, so you're looking at -1, -2, -3, -4. Okay, 1, 2, 3. On the x, you're looking at 0, 1, 2, 3. Okay, so 1 comma 4 is going to be somewhere here. Okay, so that looks like that's 0 comma -3. That's your um, y-intercept. So the curve looks like that. Mm. That is what the curve looks like. Okay. Now that is what it was supposed to be without the mod. If we bring in the mod, the actual sketch should be this part of it, this part of it, and then the 0 minus 3 becomes a 0 3. So 1 2 3 there, and the 1 minus 4 becomes a 1 4. So you are looking at something like this. Okay. So the red curve is what we should have in our uh, final sketch. And now they wanted us to show the intercepts, and that is what we're going to do. Very neatly, we'll write -1 0, 3 0, and 0 3, and no other intercept they wanted. So I'm going to keep it like that. That is it for 4 marks. Okay, let's look at another one now. The function g is defined for gx equals 4e to the power of x minus 2 minus a 1. Find an expression of g inverse x. Okay, so we go x equals 4e to the power of y minus 2 minus a 1. So x plus 1 by 4 is e to the power of y minus 2, which means ln of x plus 1 by 4 is a y minus 2. And y is supposed to be ln of x plus 1 by 4 plus r2. Well, that is the expression for g inverse x. Let's see, is that how? Okay, let's just check once. X equals 4e to the power of y minus 2 minus a 1, x plus 1 by 4. So ln of that is y minus 2, y equals to ln of x plus 1 by 4 plus a 2. Okay, so that was it for the part B. Okay, now what do we have here? Let's see. In this question, time is in seconds and displacement is in meters. A particle starts from rest at the origin O and moves in a straight line with a constant positive acceleration. See, if it's constant positive acceleration, you should know the VT curve should have a constant gradient. So it must be a straight line. And when t equals to 4, displacement is a 6. Okay, draw the velocity time graph between 0 and 4. Okay, well, if you are moving at a constant in a with constant acceleration and at a particle starts from rest, so you know that the initial velocity is a 0. Velocity at 4 seconds we don't know. Acceleration we don't know, but we do know that the displacement is a 6. Okay, so what can we do here? Although I feel like I can use the equation v square minus u square equals 2as. Uh, but is that gonna be Let's see. So v square equals 2 into a into 6. Well, we don't know what uh, v and a are, so can't use this. Mm, what else? S equals to ut plus half at square. Okay, let's see. So 6 equals u into t, that's a 0, plus a half into a into 4 seconds, 4 square. So you're looking at 6 equals 16 by 2. So a 8a, which means a is a 6 by 8. That's a 3 by 4 meter per second square. Okay. And because of that, the velocity is going to be mm, v equals acceleration into time. So 3. So reaches a speed of 3 in 4 seconds. So we are looking at a straight line like that. And let's figure out the area of this triangle. Half into base into height. So that's a 6. So yes, the distance moved is a 6. So that looks like it. But what if I don't want to do it without the formula here? What if I don't want to do it without the formula? And they have literally asked you for the acceleration in the next part, which I have already found. So this is not the correct approach then. Mm, what can I do? Let me see. I want to be, let's see. I know that v minus u by t is supposed to be the acceleration. I know that area under this straight line, wherever it may reach, let's say it reaches somewhere there. So the velocity would be a v. I know that half into 4 into v should be equal to 6. Oh, okay. Okay, I got it now. See, there is one thing we know about this sketch, which we are going to draw. Because there's supposed to be a constant positive acceleration, we know that it's supposed to be a straight line. And since it starts from rest, so it should start from here. So it should be a straight line. Let's just keep it randomly somewhere there, just to make you understand. And I know it should end at 4. Well, the area of this triangle is supposed to be half into base into height. Half into 4 into height. Height is the velocity it reaches. Uh, In this sketch here, of course, it reaches a 5, but I don't want to keep it at some fixed value. I want to keep it at v. It must be a 6. V in this case comes out to be 3. Okay. Now, that is an indication that I have drawn it. So it's supposed to, I have drawn it wrong. It's supposed to be at 3, somewhere like that. That's a sketch. Okay. So that was your uh, velocity time graph. You would want to keep a 3 out there. 3. And yes, That's it. Now, if they ask you for the acceleration, you know it's going to be v minus u divided by t, and that is 3 minus a 0 divided by 4 comes out to be 3 divided by 4 meter per second square. And this was a meter per second. Hmm. Okay. Okay, let's go do another one now. So the reason why I rejected this idea is because this is not something that you guys have been taught in math specifically. So no need. We are going to do the triangle approach for it. Place the triangle randomly anywhere. You know that the area of it is going to be half into base into height. Height is the velocity value at time equal to 4 seconds, and that's how. Okay, so half into 4 into v should be a 6, which means v is a 3. Okay, let's go to another one now. The common difference in an AP is a minus 2. So D is a minus 2. The sum of the first 4 terms is equal to the sum of the first 10 terms. Okay. So S4 is equal to S10. So you know n by 2 into 2A plus n minus 1 into D should be equal to n by 2 into 2A plus n minus 1 into D. And from here I get the value of A. Okay. So 2 times 2A plus 3 into minus 2. That's a minus 6. 5 into 2A minus 18. That's a 4A minus 12 equals 10A minus 90, which means 6A is a 78, which means A is a 78 by 6, and that's a 13. So that's your first term. And the AP looks like 13, 11, 9, 7. Okay. 5, 3, 1, minus 1, minus 3, minus 5, minus 7. That's 4 terms. And that's 10 terms. So these actually cancel out when you add them. No, not the 1. Yeah, minus 1. And the 7 also cancels out. Oh, okay. Hold on. The sum of first 4 terms, it's this thing. And there are, if there are 10 terms, there would be 1, 2, 3, 4, 5, 6, 7. Okay, so this won't be there. So these will cancel out and it stays the same 4 terms if it's okay, fine. So that is your answer. First term is a 13. Let's look at another one. Okay. A curve has equation P and Q as are stationary points on the curve. Find dy by dx in the exact length of PQ. Okay. So dy by dx. We are going to use the quotient rule. Second function into derivative of the first minus first function into derivative of the first, derivative of the second divided by the second function squared. Okay, so dy by dx now comes out to be 3 minus x into 2x minus x square minus 8 into minus 1 divided by 3 minus x whole squared. Okay. So it's gonna be 6x minus 2x square um, plus x square minus 8 divided by 3 minus x whole square. And that is gonna be what? X square plus 6x minus 8 divided by 3 minus x whole square. That looks like it. Uh, can we? factorize this? Minus 8, right? 4 into 2. No. So what am I going to do here? Minus b plus minus root over b square minus 4. So it comes out to be, oh, thirds. Okay, let's see. Are the derivatives all right? Let me just check. Second function to derivative of first minus first function to derivative of second. So 3 minus x into 2x minus x square minus 8 into minus 1. So that's 6x minus 2x square plus x square minus 8. Okay, so x square plus 6x minus 8 equals, okay. And now that they are looking for stationary point, I have to equate the derivative I got to a 0. So I get to a x square plus 6x minus 8 is a 0. And now, since it doesn't look like I can split the middle term, I'm going to use the quadratic formula minus b plus minus root over b square minus 4ac divided by 2a. So x comes out to be negative 6 plus minus 36. Okay, so minus b square minus 4ac, that's a minus 8 there, plus a 32 divided by 2. So x comes out to be 6 minus 6 plus minus root over 68 divided by 2. Mm, okay. Okay, that's why the exact length thing, because they want it to be a third kind of a question. Okay, so can we factorize this? Does it go by 4? Yes, it does. So x equals to minus 6 plus minus root over 4 into 1, 7, 17 and a 2. So you are looking at minus 6 plus minus 2 root 17 divided by 2. That's a minus 3 plus minus root 17. So x happens to be minus 3 plus root 17 and minus 3 minus root 17. Uh, we're going to have to find the y corresponding to these two x values to find out the exact length of PQ. So we have the equation here, x square minus 8 divided by 3 minus x. So let's see. Okay. So minus 3 plus root 17 squared minus 8 divided by 3 minus minus 3 plus root 17. Okay, that is one of the y's. So that's a 9. Negative 6 root 17 plus a 17 minus a 8 divided by 3 plus 3 minus root 17. Okay, that is gonna be what? 8. 18 minus 6 root 17 upon 6 minus root 17. Okay, but I don't see them canceling out. Okay. Okay, that's one y corresponding to negative 3 plus root 17. I'm going to find another y corresponding to the other x value. So x square minus 8 divided by 3 minus x. So that's negative 3 negative root 17 squared minus a 8 divided by 3 minus a minus 3 minus a root 17. And that comes out to be mm, okay. Basically 9 plus 6 root 17 plus a 17 minus a 8 whole divided by 3 plus 3 plus root 17. And that is 6 root 17. 18 plus 18 plus 6 root 17 divided by 6 plus root 17. Okay. It looks crazy. Let's see. What is going on? Okay. So x is a negative 3 plus root 17. I'm going to put up the 2 points here. Okay. P has negative 3 comma negative 3 plus root 17 as the x and 18 minus 6 root 17 divided by 6 minus 6 root 17 as the y. Q has negative 3 negative root 17 comma 18 plus 6 root 17 by 6 plus root 17 as the y. Wait, I just hope I have come up to the right values here. What is going on? How can it be this complicated? Uh, let's see. Second function derivative of first minus first function derivative of second. 3, that's 2x minus of x square minus a 1. So 6x minus 2x square. X square into minus 1. That's a minus x square plus x square. Okay. And then there's a 8 and a minus 8. So x square. Oh, there's a mistake. Oh, oh, there's a mistake. That is the mistake. Oh no. That is why the entire thing is not correct. Mm-hmm. Okay, so I'm gonna have to delete everything now. Okay, let's delete everything. I got to a root 70. That was a very ooh, dangerous, scary looking kind of a form that I got. The problem was here uh, that negative 2x square plus x square that I have, it is actually a negative x square plus a 6x minus a 8. And now it is something that can be equated to a 0 and factorized. It's a negative x square plus a 6x minus a 8 equals 0. So x square minus 6x plus a 8 equals 0. Now that breaks down into x minus 4 into x minus 2, and that is how x is a 4 and a 2. And y corresponding to these x values can actually be found out very easily. X square minus 8 upon 3 minus x. So that's a 4 square minus a 8 divided by 3 minus a 4. That's a 16. 16 minus a 8 divided by 3 minus a 4. That's a 8 by a minus 1. That's a negative 8. Okay, and for x equal to 2, y comes out to be 2 square minus a 8 divided by 3 minus a 2. That's a 4 minus 8 divided by 1. That's a minus 4. Okay, so the coordinates come out to be for PQ. The coordinates come out to be P uh, x equal to 4 and y equal to minus 8, and Q it's gonna be x equal to 2 and y is a minus 4. Now we can find out the exact length of PQ. 4 minus 2 square plus a minus 8 plus a 4 square, the distance formula. So that's 2 square plus a 4 square. That's a root of 4 plus 16. That's a root of 20. And that's a 2 root 5. Yeah, how much time have I spent? think I've spent 35 minutes already. Okay. And we are in the fifth question. Mhm. So let's go check 4, x equals 4, y is a minus 8. 16 minus 8 divided by 3 minus 4. So 8 by minus 1, so that's minus 8. And x equal to 2, y equal to 4 minus 8 upon 3 minus 2. That's a minus 4. Okay. So yes, that is your answer. Now let's move on to the sixth one. Okay, sixth one looks easy. See, that is how these are supposed to be. The paper one, non-calci kind of questions, they are easier compared to the paper two. But people tend to lose marks, like I just happened to put up root 17 everywhere, which was a mistake, and that could have set up panic in the exam. Anyways, here you've got 3x plus 2 equals 7. You can go 3x plus 2 equals minus 7, and here x comes out to be 5 by 3, and here x comes out to be minus 9 by 3, so it's a minus 3. So there, two solutions. Okay, and then they want you to solve the inequality. Well, for inequalities like these, what you want to do is square both the sides. So 4x square, so you write down square both sides. 4x square minus 16x plus a 16 is greater than x square plus 2x plus a 1. So your 3x square minus 18x plus a 15 is greater than 0. Take a 3 out common, greater than 0. That's x minus 5 into x minus 1 greater than 0. And you can draw the number line here. There's a 1, there's a 5, and take any number. Let's take a 0 somewhere here to check. 0 minus 5, 0 minus 1, that's a plus 5, that's positive. So there, you know that x should be greater than 5 and lesser than 1. That is your solution. Uh, we can check with one x value here. 2 to the power, we can do a 2 into 6 minus 4 mod. That's a 8. 8 is greater than 6 plus 1. Yeah, so 7. Yes, it works. So correct answer here, 4 marks. Okay, let's see what's happening here. The variables x and y are related to use calculus to find the approximate changes. Okay, so I know that the formula for approximate changes is delta y equals dy by dx at some given x value multiplied by the change in x. Okay, so I'm going to go find out dy by dx first. Well, that is going to be 3 divided by 2 root x and x to the power of minus 1 by 2, right? This one. So minus 1 by 2 into x to the power of minus 3 by 2. It's going to be. Okay, and this is to be obtained at x equal to 4. So we are looking at 3 by 2 root 4 minus a 1 by 2 into 4 to the power of minus 3 by 2. Well, that is 3 by 4 minus a 1 by 2 into 4 to the power of 1 by 2, right? That's a 2. 2 to the power of minus 3 is a 1 by 8. So you're looking at 3 by 4 minus 1 by 16. So that's a 12 by, no, 9 by 16. 9 by, oh, 12 by 16 minus 1 by 16. That's a 11 by 16. Okay. So approximate change in y is gonna be 11 by 16 into the change in x, which was a h. So 11h by 16 is your answer for this. Hmm. Let's see this thing once again. Minus 1 by 2x to the power of minus 3 by 2. Let's put up a 4 here. So 3 by 4 minus 1 by 2 into 4 to the power of, that's a 2, 2 to the power of minus 3. It's minus, so 1 by 8. So 3 by 4 minus 1 by 16, 4 LCM, 11 by 16, 11h by 16. Okay. So that was the 11th one. Okay, now let's see. They're saying find dy by dx. Okay, so I use product rule. Dy by dx is gonna be x into derivative of e to the power of 2x plus 1 plus e to the power of 2x plus 1 into derivative of x. Well, that's x 2e to the power of 2x plus 1. That is the derivative of this thing, chain rule, and that is 2e to the power of 2x plus 1. And dy by dx comes out to be e to the power of 2x plus 1 out common with a 2x plus 1 inside. There. That is the derivative. Okay. Now the line L is tangent to the curve at x equal to 1 by 2. Okay, so let's do this one now. I can find out the m value at x equal to 1 by 2. And that is going to be e to the power of 2 into 2. When you substitute x equal to 1 by 2 here and there. E to the power of 2 and 2e square. Okay. And I can find out the y corresponding to x equal to 1 by 2. It's going to be 1 by 2 e to the power of 2. So e square by 2. So the equation, we can find out the c from here. Y equals to mx plus c. So e square by 2 equals 2e square into 1 by 2 plus c, which means c is e square by 2 minus e square. That's a negative e square by 2. Okay, so equation, find the exact coordinates of the 2 points where the L meets the axes. Okay. So the equation of the tangent comes out to be y equal to m x plus c. Okay. Now the y-intercept of it and the x-intercept of it can be found. Let's go figure out the x-intercept. That's when y is a 0. So 2e square into x minus e square by 2. Now e square by 2 equals 2e square x, which means x is 1 by 4. And the y-intercept is gonna be when x is a 0. So comes out to be 2e square into 0 minus I e square by 2. So it's 1 by 4 comma a 0. That's your x-intercept. And 0 comma minus e square by 2 is your y-intercept. And when they say exact coordinates, you have to retain the E form of it. You can't, of course, you're not allowed a calculator in this paper, so you have to keep it with the E there. Okay. Okay, good. That was the 8th one. Let's look at the 9th one. Oh, now they want me to integrate it. Oh, okay, 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 okay. Okay, so I'm gonna have to bring my result from the derivative here. Okay. So I know that derivative of y was a 2x plus 1 into e to the power of 2x plus 1, which means integral of that derivative should be equal to y, the equation here, y, the expression here, x e to the power of 2x plus 1, x e to the power of 2x plus 1 plus a c. Okay. Hmm. Okay, so using integration as the reverse of differentiation, I know that the derivative integrated, this thing integrated is y. Well, that is what I'm going to use. This is what I'm going to use to get that. So I'm going to have to isolate this. I'm going to have to isolate this from this guy. Okay, so we are going to uh, separate them into different terms there. And that's 1 by 2 e to the power of 2x plus 1 equals x e to the power of 2x plus 1 plus a c. And see, I have isolated what I wanted. This is here. So 2 times integral of x e to the power of 2x plus 1 dx is x e to the power of 2x plus 1 minus a e to the power of 2x plus 1 divided by 2 plus a c. Okay. And I can divide both the sides by a 2 now. So integral of x to the power of x e to the power of 2x dx equals this divided by a 2. Or you can keep the 2 out there minus this by a 2 plus a c. That is it. That is the result. So the whole thing, this whole thing divided by a 2, there, 1 by 2. Divided by a 2 or multiply by a 1 by 2, one and the same thing. That looks all right to me. Almost an hour now. Is it? 50 minutes. 50 minutes. Okay. I hope I've not done something silly anywhere. Okay. Okay. Let's look at the vector question. Now on the ninth one. In this question, time is in seconds and distances are in meters. A starts with A starts at the origin. So you know that the original position for A is a 0, 0. And the velocity of it is 2, 1. Okay. At the same time, B starts from the point with the position vector. So for B, the original position is minus 3, 4, and velocity is 4 minus 2. Write down the position vector of B at time t. Okay, so you use the formula P equals P naught plus Vt. So minus 3, 4 is where it starts. 4 minus 2 is the velocity. So you're looking at negative 3 plus 4t and 4 minus 2t. That is your position vector for B. Let's also find out the position vector for this part, position vector of A at time t. For A, P equals P naught plus Vt. So that's 0, 0 plus 2, 1t. So that's a 2t and a t. Determine whether or not the particles collide. Well, for the particles to collide, you know that the x of position vector for B and x for position vector of A should be the same. So negative 3 plus 4t should be equal to 2t, which gets you t equals 3 by 2 seconds. 4 2t minus 2t equals to minus 3, t equals to 3 by 2. And let's equate the y's also. This and that. Well, 4 minus 2t equals t, which means t is a 4 by 3 seconds. Well, you cannot have two time values since we get different values of t when the positions of A and B are equated. It means they never collide. We could have gotten at least one value of time here, but yeah, they don't actually. They don't match. That is why. Okay, so that was the ninth one. Okay, and the point Q has a position vector of 3, 2. R has a position vector of minus 1, 4, and S has a position vector of A, B. Mm, S lies on QR and RS is a root 5. Well, I'm going to go find out RS. Well, RS I can say is RQ plus QS. And what else can I say here? Well, those are OQ, OR, and OS for you, right? I could have done something else. I know RS can be written as RO plus OS. Okay. RO is a 1 minus 4 and OS is a AB, and that gives me a plus 1 and a B minus 4 on the vector. That is RS vector. Okay. I also know that S is on the line QR. Okay, so there it is. Let's say this is QR, S is somewhere here. So I also know that QS should be some K times QR. Okay, so that is what I'm going to use. QO plus OS is K times QO plus OR, and QO mhm, is a negative 3, 2. OS is a AB equals K times negative 3. Oh, negative 3, negative 2. Negative 3, negative 2 plus a OR. So minus 1, 4. Okay. So negative 3 plus a A, negative 2 plus a B is equal to negative 4k and a 2k. Okay. How do I do it now? Okay. Well, I see that negative 3 plus A is a negative 4k. Okay, okay. So I know that A is gonna be negative 4k plus a 3. And I also see that negative 2 plus B is a 2k, which means B is gonna be 2k plus 2. Hmm. I can actually eliminate, if I bring k from here, I will, if I bring k from here and in terms of A, I will have B in terms of A. Find the possible values of A and B. Oh, nice. Okay, so I'll bring k from here. So you are looking at k equals 3 minus A by 4. So B equals 2 times 3 minus 4. Oh, 3 minus A by 4 plus R2. And that is B equals 3 minus A by 2 plus R2, or 1 minus A by R2. If you take the LCM of 2 here, so that's a 4 by 2. Oh no, 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 no. So if you take the LCM, it's gonna be 3 minus A plus of 4. That's a 7 minus A by a 2. That's what B is gonna be. 7 minus A by a 2. The thing is, I actually want to check. I want to check my answer for once. I just don't want to correct it all the way up. RS is a RO plus OS. 1 minus 4 AB. A plus 1 B minus 4. That is correct. And I know that QS is some fraction of QR. So QO plus OS is KO plus OR. QO is negative 3, negative 2. OS is a AB. K times negative 3 plus OR. OR is negative 1, 4. Okay, so minus 4 plus 2K. Okay, this negative minus 2. Okay, so I have a negative 3A. Negative 3 plus A is a minus 4K. Negative 2 plus B is a 2K. From here, I get K is a 3 minus A by 4. 3 minus A by 4, 3 minus A by 2. So that's a 7 minus A by 2. Now I'll bring back RS. Well, I know RS is A plus 1 by B minus 4. Okay. And I know that B is a 7 minus A. So I'm going to bring that in. 7 minus a by 2 minus a 4, and that is a plus 1 with a 2 out there, minus a minus 1. 7 minus a minus 8, so that's minus a minus 1 by 2, or that's rs. But I know that the magnitude of rs is root 5. So rs squared is a 5. The magnitude squared is a 5. This thing. So you're looking at a plus 1 whole square plus a minus 1 by 2 whole square should be a 5. I'm going to solve for a now. So a square plus 2a plus a 1 plus a square plus a 2a plus a 1 divided by 4 is a 5. So that's a 4a square plus a 8a plus a 4 plus a square equals 20. So you are looking at 5a square plus a 10a plus a 5 equals 20. That's a 5a square plus a 10a minus a 15 equals 0. A square plus 2a minus a 3 equals 0. That's a plus 3 into a minus 1 equals 0. A is a minus 3 and a 1. And you know that B is supposed to be 7 minus a by 2. So for a equals to minus 3, it comes out to be 7 plus 3 by a 2. That's a 5. And for a equals to 1, comes out to be 3. So a is minus 3 or 1, and b is a 5 or a 3 for 5 marks. Mm, okay. 1 hour already. That's too much though. I actually want to see what this vector looks like. How many questions do I have remaining though? 10, 11, and 12. 3 questions remaining. 10 marks, 16, and 8. 24 marks remaining. Okay. So I have Q, which is a 3, 2. I have R, which is a minus 1, 4. And I have S, which is a which is either a minus 3, 5 or a 1, 3. 3, 2, minus 1, 4, either minus 3, 5 or a 1, 3. So I'm going to have to, I'll draw these vectors, okay? Let's see. Let's draw them here. Hmm. So 3, 2, 3, 2. That's OQ. Minus 1, 4. Minus 1 there. That's, and S is either a minus 3, 5. Minus 3 and a 5. there, and 1 and a 3. Oh, yeah. It actually lies on that line. Look at that. If I join, S actually falls. That's Q for you. That's R for you. And that's one possibility for S, a 1, 3. And the other possibility of S is a minus 3, 5. So, yes, S lies on QR. Hmm. Nice. Okay. Oh, this is a 6 marker. Well, I can actually see that log of x to the base of log of 5 to the base of x, or x to the base of 5 is supposed to be taken as some y or some variable. Well, this is 2 log of x to the base of 5. That is log of x to the base of 5 minus 3 by log of x to the base of 5 equals 2. Now these two reduce to a log of x to the base of 5 minus 3 by log of x to the base of 5, and it is a 2. So you are looking at y minus 3 by y equals 2. So you are looking at y square minus 3 equals 2y, or a y square minus 2y minus 3 equals 0, and that brings you to y minus 3 into y plus 1 is a 0. So you are looking at y equal to 3 and y equal to minus 1. So log of x to the base of 5 is a 3, which means x is a 5 cube, which is a 125. And log of x to the base of 5 is a minus 1, which means x is a 5 to the power of minus 1. It's a 1 by 5. I wonder why it's a 6 marker though. Okay. So that was it with this one, 10 part A. Okay, this I need to bring them all to the basis of 2. So you go 2 into 2 to the power of 3 to the power of 2x plus 1 minus 3 into 2 to the power of 3x plus 4 minus 64 is a 0. So that's basically a 2 into 2 to the power of 6x plus 3 minus 3 into 2 to the power of 3x plus 4 minus a 64 is a 0. That's 2 into 2 to the power of 3x to the power of 2 into 2 to the power of 3 minus 3 into 2 to the power of 3x into 2 to the power of 4 minus 64 is a 0. See, that can be split, right? 2 to the power of 6x plus 3 can be split into 2 to the power of 6x into 2 to the power of 3. And that can be written as 2 to the power of 3x squared, right? Same here. This can be split into these two. Well, that helps you assume 2 to the power of 3x to be a y. Now you're looking at 8 into 2, 16 y square minus 2 to the power of 4, that's a 16, 48y minus 64 is a 0. Divide both the sides by a 16. And you are looking at y minus 4 into y plus 1 is a 0. So y is a 4 and y is a minus 1. So 2 to the power of 3x is a 4. That's 2 square. So 3x is a 2. So x is a 2 by 3. Or 2 to the power of 3x is a minus 1. Which can never be true. So there's it. That's it. That's x equal to 2 by 3 is your answer. Okay. Now let's go do another one. The area of the region enclosed by the curve in the x-axis is 9 by 16. Find the value of A. Oh, nice. Okay. Well, this looks like a curve which is upside down. And also, I see that the y-intercept of it is negative. You see, that negative x square means it's upside down. And if I find out the y-intercept of it, it's a 0 and a minus 2a square. So this curve is actually not only flipped, it also has a uh, negative y-intercept. Okay. How is that going to change anything? I'm going to try to find out the x-intercepts if there are any of it. So 0 equals negative x square plus 3ax minus a 2a square. So x is going to be minus b plus minus root over b square minus 4ac divided by 2a. So x comes out to be negative 3a plus minus root of 9a square minus a 8a square divided by a negative 2. That's a negative 3a plus minus a divided by a negative 2. That's a minus 4a by a 2 and a negative 2a by a 2. So x comes out to be negative 2a and a negative a. Okay. Okay, so let's try to figure out the sketch of it. Mm, the curve is gonna look like it has I think, see, this is where it gets difficult. Okay. So, like I have been telling you, the last questions are supposed to be the one which differentiate a great score from a good score. Okay. So, I think this is the one. Uh, so, y intercept is a negative 2a square. Let's place it somewhere here, maybe. Negative 2a and a, they can be out there, and it has to be flipped. So you are looking at something which goes like that. That's what it looks like. And the area trapped is this thing. That's the area trapped. Hmm. I know that the vertex of it must be positive. Let's see. Y1, so the vertex is going to be right in between these two, negative 3a by 2. That is where the vertex is going to be. If I substitute negative 3a by 2, so that's negative 2a, negative a divided by 2. That's the x coordinate of the vertex. X1 plus x2 divided by 2. X1 plus x2 divided by 2. That is the x-intercept of the vertex. And the y is going to be negative of negative 3a by 2 squared plus 3a times negative 3a by 2 minus a 2a square. That's a negative 9a square by 4, negative 9a square by 2, negative 2a square. And what is going on? How can it have a negative vertex like that? The area of the region enclosed by the curve in the x-axis. This is definitely a curve which is flipped. Negative x square plus a 3ax minus a 2a square. Am I? Oh yeah, negative 3a by 2. This thing comes out to be negative though. What is it at a? Negative a square minus 3a square minus 2a square. No, 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 no. Negative of negative a square plus a 3a into negative a minus a 2a square. That's a negative a square minus a 3a square minus a 2a square. It doesn't come out to be a 0. Do I have the wrong coordinates here? Okay, okay, okay. I think I need to correct my x-intercepts. Minus b plus minus root over b square minus 4 a c. Yes. Oh no. By a minus 2. Oh yeah, that's the mistake. Got it. Got it. That's the mistake. There's a minus 2 out here. So it's a plus 2a and a plus a. Those are the x-intercepts. Okay, that is why. So that was the mistake. Now, this is not where the curve will be for us. It is supposed to be on the other side there. So we are looking at something which looks like that. And this is the area we have. That's literally A and 2A. So the curve has been integrated between A and 2A to come to a 9 by 16. Nice. What time is it? 6:35. I have one more question to do. Okay. Okay, so there we are. We found out the x-intercept. So in a way, we tried to sketch the curve. We tried to sketch the curve. I know that this is a 0 comma negative 2a square, and x-intercepts came out to be a and 2a. Okay, so there, and we're gonna go integrated between a and 2a now. So I go negative x cubed by 3 plus a 3ax square by 2 minus a 2a square x between a and 2a is 9 by 16. Okay, okay, that looks like a good lot of work already. So negative of 2a cube by a 3 plus a 3a into 2a squared by a 2 minus 2a square into 2a minus a negative of a cube by a 3 plus a 3a into a square by a 2 minus 2a square into a should be a 9 by 16. Okay, so that's negative 8a cube by a 3 plus a 12a cube by a 2 minus a 4a cube minus a cube by 3 plus a 3a cube by 2 minus a 2a cube, and that's a 9 by 16. Okay, so I'm gonna go it's negative 8a cube by 3 plus a 6a cube minus a 4a cube plus a cube by 3 minus a 3a cube by 2 plus a 2a cube, and it's a 9 by 16. And we are looking at these two, 2a cube added with that, that's a 4a cube. These two, it's a negative 7a cube by a 3. And then there is a negative 3a cube by a 2, and it's a 9 by 16. Whew. A cube minus 7 by 3 plus a 4 minus a 3 by 2 is a 9 by 16. Let's take the LCM of 6 here. That's a negative 14 plus a 24 minus a 9 equals 9 by 16 into a cube. A cube is 1 by 6 equals 9 by 16. A cube is a 9 by 16 into 6. That's 8 and a 3. That's a 27 by 8. And that is how A comes out to be cube root of 27 by 8. That's a very nice 3 divided by 2. Oh, no. Oh, 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 that is crazy. Oh, no, 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 no. Oh, ho, 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 ho. Good that questions like these are at the end, so you don't have to go down. Go down a rabbit hole judging your prep and stuff like that. You can actually take some time, do the first questions quickly and accurately, and spend a good lot of time here. Questions like these. Okay. So you are looking at A equals to 3 by 2. Wow. Okay. And now there's points of intersection of two circles. So we equate the two uh, points of intersections of two circles. So we equate. We know that x square plus 2x plus y square minus a 4y minus a 20 is equal to x square minus 12x plus a y square minus a 6y plus a 20. Thankfully, these will go away. You are looking at 14x plus a 2y equals 40, which means 7x plus y is at 20, which means y is at 20 minus 7x. Well, I know the points of intersection of the circles are parts of the circle. So the coordinates I get should satisfy these equations also. So not only do I have a linear relationship between the coordinates, I have these also, other relationships. So I can use any one of them to find out uh, the x and y. I'm going to use y equal to 20 minus 7x and substitute it anywhere there. Maybe I'll do it in the first equation. So you're looking at x square plus 2x plus a y minus a 4 times minus a 20 equals 0. That's x square plus 2x plus a 400 minus a 280x plus a 49x square minus a 80 plus a 28x minus a 20 equals 0, and that's a 50x square. And we are going to have to club this, and this together. That's a 2830, and that's a negative 250x, and 400, that's 320, and 320 minus 20, that's a 300 equals 0. So you're looking at x square minus 5x plus 6 equals 0, which means it's a x minus 6 into a, oh no, x minus 3 into a x minus 2 equal to a 0. So x is a 3 and a 2. And of course, y we can find out. Y is a 20 minus 7x, so 20 minus 7 into 3, that's a minus 1. Or 20 minus 7 into 2, that's a 6. So the coordinates are 3 with a minus 1 and 2 with a 6. Hmm. So those are your coordinates. That looks like all there is in this paper. I think I took about, so we started at 5:16 and we ended at 6:43. So that's like 1 hour and 28 minutes. It's still slower than some of the people that I've done the paper with. Some of the kids actually from your senior batches. I've seen them do it in 1 hour also, these paper ones. But yeah, I uh, was discussing and I did a few mistakes also. I had to correct them and stuff. So, yes, let's go look at it from the beginning. Uh, I will stop at these solutions. If you want, you can take screenshots. So that I did a mistake here and I had to correct it. Okay. This is a nice thing. 4x square minus 1, people may stop it here. But you should know that it's a square minus b square kind of a thing. So a minus b into a plus b. Let's go to look at the other one. Let's connect them. This one. And then there is this one. So you have found the x-intercepts here and the y-intercept and the vertex. Mhm. 1 minus 5, right? Mm-hmm. Okay. Now this is the inverse that you had to find. Oh, okay. This looks all right to me. Oh, this was that thing. Oh, yeah. I know it's supposed to be a straight line. So area of the triangle should be the displacement you have. Half into 4 into some v should be equal to. That was the wrong thing to do. This was correct. Half into 4 into v. Half into 4 into v should be a 6. The displacement, the area under the triangle should be, the area under that straight line should be a 6. So half into 4 into v is a 6. So that's how we know v is a 3. Okay. So acceleration comes out to be 3 by 4. Okay. So that was this thing. Now this one. And then dy by dx. Stationary point thing. I did a mistake here. Minus x square thing. I forgot that negative x square. I just hope this one is correct though, man. I don't have the patience to um, check my answers right now. 4 and a minus 8, 2 and a minus 4. Okay. This one, minus 9 by 3. And there's this one, 4 to 8, 16, 16. It depends on 3x square minus 18x plus 15, x square minus 6x, x minus 5 into x minus 1. So x is a 5 and a 1. Mm, yeah, this is correct. Approximate changes now. 3 by 2 root x minus 1 by 2 x to the power of minus 3 by 2 at the x equals 4. So that's 2 to the power of minus 3 plus 1 by 8. 3 by 2 into 2. That's 3 by 4 minus 1 by 16. 11 by 16. Okay. Okay, this was that. Even this one was a good one. M comes out to be 2e square. Yeah. Y is a e square by 2. Okay. So e square by 2. 2e square into 1 by 2 plus a c. That is your c value. So it's going to be e by 2 square by 2 minus e square. That's a negative e square by 2. Y equals mx plus c. So the x-intercept is going to be 1 by 4. Y-intercept is 1 by 2. Okay. And then there is this integration thing. Okay. Okay. And it was a nice one though. So what we did here is we came to an expression of RS in A and B, and then the fact that QS should be a fraction. Oh, this was a good one. Let's, this was the whole question. Let's bring this thing out here and see. Can I? Oh no. Oh. Okay. So first RS is a RO plus OS. So RS comes out to be this. And then QS is Q K times QR. So from there I figure out B is a 7 minus A by 2. Let's divide it into parts. This is one part of it. And then there is this part of it. And then there is this part of it. So you'd want to take screenshots there, one part, two part, one first part, second part, and then you can do this one. Hmm. So for this one, x comes out to be 2 by 3. And this one was the craziest question. Oh no. Yeah. There. This was a good one. 9 by 16. You want to take the screenshot of this one though. Okay. And then that's the 11th, 12th one. All done. Okay. Okay. So that was the whole paper. I'll see. maybe I'll put up the marks next time. But that's it for today. Bye bye.